Did you know that bullets outdated the invention of firearms? The process of making bullets involves a series of different steps, each one with rigorous protocols. Join us as we dive into the intricate details of how bullets are made. Preparing materials. The first thing that has to be done when it comes to making bullets is the preparation of raw materials. Common examples of such raw materials include an abundance of lead, copper, and brass. These materials are both robust and flexible, making them essential for the production of ammunition. The raw materials to the foundry, also known as the melting facility. In the facility, the lead is melted and turned into a liquid. During this stage, it is cleaned and prepared for shaping, which is why this is a significant step in the process. The cleaning process is also being performed on copper and brass at the same time as the cleaning of steel. As far as bullet cases are concerned, they are prepared as the material is rolled into thin sheets. For the production of circular bullets, molten lead is poured into molds, and for the production of long, thin bars, it is pushed out of a die. There is a connection between these two events. It is simpler to deal with these shapes, and subsequent modifications can be made to them so that they constitute the bullet's core. One of the factors that could potentially have an impact on the effectiveness of the bullet is the degree of precision with which these bars and billets are manufactured. After the lead pieces have been melted, it takes some time for them to cool down and become more rigid. It is essential to monitor this cooling process in order to prevent the material from becoming twisted or fractured as a result of the rapid shift in temperature. After being allowed to cool down, the cores are verified to ensure that they are of high quality. Sheets of copper and brass are used in the mass production of bullets. Generally, these sheets are kept in a warehouse or some other storage place that was constructed specifically for the purpose of storing raw materials. Raw materials are kept in the warehouses to ensure that they remain in the best possible condition before they are transformed into bullet jackets. Pressing the bullet cores. As soon as the lead billets and rods have been cooled down and examined for the quality, they are transferred to the pressing line. In this step, the lead is chopped into pieces precisely and consistently, and each piece is weighed to determine the exact weight required for the bullet. In the core forming area, chunks of lead are placed into high-pressure machinery. These devices apply a significant amount of force on the bits to crush them into conical or cylinder forms, depending on the bullet shape. This pressing technique results in a compact and consistent lead core that serves as a solid foundation upon which to construct the bullet. In the subsequent step, the pressed cores are put through a series of calibration units that record their diameter and weight. Automated machinery inspects the size of each core, and only those that do not conform to the stringent specifications are discarded. By following this technique, manufacturers are able to rest assured that every bullet will have the same ballistic characteristics, which will ensure a consistent outcome. Shaping the jacket. During the time that the bullet cores are being pressed, other workers get the sheets of copper and brass ready to be used as coats. Machines are used to roll and smooth metal sheets into long strips. These sheets are fed into the machines. Following this step, these strips are sliced into smaller blanks, with each blank being manufactured to accommodate a particular size of bullet. Due to the fact that the jacket's primary function is to safeguard the core and maintain the shape of the bullet, the quality and thickness of the metal are equally important. Stamping tools such as drawing, forming, trimming, and header dies are used in the manufacturing process of bullet jackets. These stamping tools shape and trim metal into precise bullet jackets, and when the tools are equipped with the dies, they can create the cups deeper with each pass while maintaining the shape of the metal. Immediately following the formation of the jackets into cups, they're heated to a particular temperature and then progressively cooled in order to relax any metal that is still stiff as a result of the pressing process. This results in the metal becoming slightly more malleable, making it easier to shape without the possibility of it breaking. Following the annealing process, the bullet jackets are manufactured with sized dies, trimming machines, and finishing dies to achieve precise specifications. This phase guarantees that the system functions effectively when it is in the air by ensuring that each jacket fits snugly around the lead core and remains the same throughout the process. Assembling the bullet. It is time to put together the jackets and lead cores once they've been molded and pressed into their respective shapes. When it comes to the production of modern bullets, the process of matching lead cores and jackets according to their particular caliber is frequently automated. The Waterbury Ferro machine is an advanced machine capable of performing these tasks effectively within a single continuous cycle. These machines are responsible for a variety of different procedures, including drawing, inserting, and sealing lead cores into copper jackets and feeding the cups. These processes are important in order to guarantee high-quality bullets with consistent ballistic accuracy. This automated automation enables firms to successfully manage production runs and maintain stringent quality control without sacrificing efficiency. The bullet's weight distribution, which affects its accuracy and range, also makes depth an essential factor. Once the core has been positioned correctly, the machine presses it into the jacket one more time. After the components have been assembled, they are put through crimping tools which tighten the jacket around the core and confirm that it meets the requirements for a good fit. Machines may also add a cannelure, which is a tiny ring that wraps around the jacket and aids in sealing the bullet into the cartridge case later. It is because of this that the bullet is prevented from traveling forward or backwards within the case when a firearm is shot. Immediately following the crimping process, the bullets are moved to the final form station. They can have a hollow tip, a round nose, or a Spitzer nose. The shape of the nose is determined based on the intended function of the bullets. The machines use different pressure levels to stabilize the shape, which is a crucial component for explosive performance. Quality control. When the bullets have been assembled and formed, they are then transported to the inspection section, where they are subjected to a thorough quality check. This multi-step process ensures that only ammunition of the highest possible quality is sent to the market. Technicians inspect each bullet at the inspection stations. During inspection, they look for surface flaws such as cracks, dents, and other issues that could potentially damage the bullet's ability to function. They can locate even the most insignificant errors with the assistance of magnifying equipment and solid lights. If a bullet does not pass a quality inspection, it can be thrown away. Following the completion of the manufacturing process, the bullets are subjected to a dimensional testing apparatus. It is the responsibility of this apparatus to guarantee that each bullet satisfies the exact specifications for its weight by employing precise measuring tools. These tools examine the length, width, and shape of the bullet to determine whether or not any variations could interfere with its accuracy. The manufacturing process involves the use of machines such as gauge and weight machines and visual inspection machines, which are designed to automatically dispose of bullets that do not conform to the stringent size specifications. The use of this equipment guarantees that every bullet meets the requirements that are necessary for quality performance. The next phase is the process that has to do with correcting the weight of the bullets. After being placed on sensitive data scales, bullets are checked to confirm that they fulfill the mass standards that have already been defined. The ballistic performance can be less stable, even with slight minor adjustments. The scales are connected to a system that separates the bullets into those that are in accordance with the criteria and those that are either too light or too heavy. Testing. Once quality control has approved them, the bullets are prepared to undergo a series of tests at a predetermined shooting range. These tests guarantee that they are effective in situations of need. Professional engineers create test plans in order to ensure that critical aspects such as impact, velocity, and accuracy are checked. The individuals who are in charge of making the guidelines take into consideration all the applications of the bullets, such as for police and military use. In order for bullets to be certified for sale, they must first satisfy the precise quality standards that are established by each type of inspection process. Technicians choose guns that are appropriate size for the rounds. Then, these firearms are meticulously calibrated and cleaned to exclude any external influences that might impact the test's outcomes. Marksmen fire their weapons at targets, and ballistic gelatin blocks are positioned at varying distances. For the purpose of recording the bullet's tracks and providing information on their spin, stability, and trajectory, cameras that operate at extremely fast speeds are utilized. The rate at which the bullets move as they exit the barrel is another measurement that chronographs keep track of. Technicians inspect the bullets after they have struck their targets to determine the degree to which they have altered shape and to the depth to which they have penetrated. By doing so, the bullets are guaranteed to perform as needed. Certain bullets are put through rigorous testing in controlled circumstances to guarantee that they are effective in a variety of settings. In order to determine how well they function, they are put through rigorous testing in difficult situations such as high humidity and a wide range of temperatures. And that is how bullets are made, a complex process that spans multiple steps where each one can influence the end results and needs to be performed with great precision. Stay tuned for our next video, where we will explore more interesting things.